Hi students, welcome to Alpha C learning program mathematics class. We have started parabola, and in parabola in previous session we have observed different kinds of standard forms, that is axes are along coordinate axis, at the same time parallel to coordinate axis. Still some another kind of parabolas also there, those are known as oblique parabola, and after reading, that means after doing some problems and concepts, we can go for even oblique parabola also. Now students, observe here some concepts which we have observed in parabola, where axis is along here coordinate axis, or else axis is exactly parallel to coordinate axis. Okay, now these are some rules which are applicable for any kind of parabola. Any kind in the sense means horizontal, that means here left side open, right side open, again open upwards, open downwards, and next one is oblique. Oblique means if parabolas are of this model, if these are in this way, then we say those are oblique parabola, where axis is not here parallel to x-axis or y-axis. Okay, that means whatever rules here we wrote here, these are not only for not normal parabolas, these are for any kind of parabola. Observe here students, one by one points we can observe here. One is here focus always lies inside the curve and directrix is here outside the curve. Okay, that means here already we have taken the standard form everything. Once you have taken focus here, then directrix we are taking like this. Okay, when the axis is here along coordinate axis. And suppose here focus is exactly some point here, a fixed point, and this one is here directrix, then the curve we have observed like this, isn't it? The curve is observing like this. That means whatever the directrix you got, the directrix is neither touches the curve nor intersecting the curve. Now we may get here one doubt, that is what will happen if focus is on the directrix. Okay, if exactly focus is on the directrix, then the locus of P is nothing but pair of lines which are passing through focus. Let us observe here, suppose a point I am taking, that is -1, 1 as here focus I am taking. Okay, -1, 1 as focus I am taking, and directrix I am taking here x plus y equal to 0. So clearly you can observe here this point is satisfying the curve equation. And once I got in this way, this is -1, 1 and directrix is x plus y is 0, then we can say clearly students in this one, that is if I substitute -1 plus 1, it is coming 0. Now the concept is here, conic concept is nothing but here SP equal to E times PM. So E also I am taking for example 1. Okay, E times PM. Then SP equal to EPM. What is the meaning here? If we write in this way, then you can observe here x plus 1 whole square. Understand? X comma y be any point on the locus. So x plus 1 whole square and plus y minus 1 whole square, and E I am taking as 1, then this is nothing but here x plus y whole square divided by 2. Perpendicular distance if you use. Then if you do cross multiplication, it is 2x square minus x square. What is the value? It is x square, right? And next 2y square minus y square, that is plus y square. After that you will get here 2xy, that is minus 2xy. Moreover, here we are getting plus 2x. 2 into means it is plus 4x, and this is minus 4y. And next here 1 plus 1 2, and 2 into 2 you will get here 4. That implies this is nothing but completely the first 3 terms you have been observing, it is nothing but a perfect square. And total also if you observe, it is nothing but x minus y plus 2 whole square you will get. That means clearly we can say the locus is nothing but what here? Pair of lines. Moreover, these are here whole square means they are coincident, isn't it? Coincident you got. And observe here the focus also -1 if I substitute, -1 and 1 here, so -2 plus 2 you got here 0. Understand? That means here whenever focus is exactly on the directrix, then the locus of P is nothing but pair of lines, and those pair of lines also here finally they pass through here focus. Here I got the value coincident lines because of the reason I have taken eccentricity equal to 1, and here you got h square equal to AB. So delta not equal to 0 you got here, eccentricity is 1 here, and moreover h square equal to AB here. Therefore finally you got coincident lines is our locus, and those coincident lines also they pass through which point here? Focus. Therefore if at all you got any doubt what happened if focus is on directrix, then now you can clarify the doubt, that is the locus is nothing but pair of lines which are passing through origin. Okay, and next one is here the second point. So first point what we have observed here, the focus always inside the curve whereas the directrix is outside the curve. And next one is here focus comma vertex, they lie on same side of directrix, isn't it? Any kind of parabola you take, this is the directrix you observe, and this one is the focus, and this is our vertex. How are these two actually? These are on same side of directrix. These kind of same side, opposite side you have observed already in circles. They play a vital role while solving problems because options there seems to be both options are right in that way. But just by using this kind of concept you can decide exactly which answer is 100% right. Okay. So this is one of the important concepts, that is focus and vertex they lie on same side of directrix. Okay. And next one is here length of latus rectum. What about here length of latus rectum? If it is the standard parabola, we have observed the length of latus rectum is nothing but 4a. Okay, that means here if it is the parabola standard model, y square equal to 4ax, and this is our latus rectum which is passing through focus and perpendicular to axis of parabola, right? And then we have observed this length LL dash is nothing but what here? 4a. But here this is only for standard form, you can say the length is nothing but here 4a. Suppose if it is making in this way like this, if it is falling that one, then this is our length of latus rectum. Again we consider that one as 4a. Again if it is upwards or downwards, we have taken length of latus rectum as 4a itself, right? But actually these are all true, it's okay for whenever the parabola whose axis is along x-axis or parallel to x-axis, along y-axis or parallel to y-axis. But every time that may not happen, then what we can consider there? At that stage here, you can make use of the standard form. How we have taken that one as length of latus rectum. Okay, that means while doing the standard form, students, we have taken this is the parabola and this is our focus, this is A and this is the directrix Z. Okay, that means from the focus if you take perpendicular distance on directrix, okay, from the focus if you take perpendicular distance on directrix, that one is here 2a, because this is A here, this is A here, then exactly you can say here 2 times the distance between focus to directrix. Okay, in other words also we can say that is 4 times distance between focus and vertex. That means this value 4 times distance between focus and vertex. So once you proved here the concepts for the standard form, you can generalize in this way, not as coordinates wise, isn't it? Coordinates you can't generalize, but you can generalize here distances. Only distances we can do. Therefore, length of latus rectum for any kind of parabola, any in the sense oblique parabola or else this kind of parabola, we can say it is nothing but 4 times distance between focus to here, how much? Vertex. Or else it is 2 times focus to which one here? It is directrix. A very important formula this one. Okay, this is length of latus rectum in terms of focus and vertex, and the other one is in terms of focus to directrix. Okay, And next one is here, focus vertex they lie on axis of parabola. Now these concepts are very useful while solving problems. They give here focus vertex and equation of axis, then directly you can find here 2-point form, and some other condition they give, they will ask about equation of directrix, then you can find here slope, then directrix slope is exactly -1/m if this slope is here m. Okay, therefore you can say focus vertex, both of them they lie on axis of parabola. Okay. And next one is here, axis is perpendicular to what values here, directrix, latus rectum, and the other one is here tangentiate vertex. Okay, so focus, that means here axis is perpendicular to directrix, because you know this is the axis of parabola, and if this is the parabola you are having, then this one is here latus rectum, and next one this is our tangentiate vertex, and after that this is our directrix. Now these three lines you can observe here clearly, they are perpendicular to axis of our parabola. Suppose the parabola is coming like this, that means oblique, then also we can say this is tangentiate vertex, this is directrix, and this is here latus rectum, and thereby we can say this is actually our axis. Okay, now here also axis is perpendicular to latus rectum, and next one here tangentiate vertex, again at directrix. So here axis is perpendicular to these values, right? And next one is curve is symmetric about its axis. However, the curve you have considered, that means this one, this type of parabola or this type of parabola, but it is symmetric about its axis. What is the meaning of symmetric here? The meaning of symmetric is nothing but whatever the portion curve is occupying to the left side or this side of axis, same portion it is falling to the other side of axis also. Okay, here we can say above and below, and if parabola is like this, then we say right side, left side, and if parabola is like this, then to the left side of axis or to the right side of axis, the curve is taking same kind of nature, that is same portion. Whatever this length here, same as here this length also. Okay. Now, so here you observe axis is here, that means here the curve is symmetric about its axis. Sometimes in problems they ask about find equation of a line where the curve is exactly symmetric. Then the line is nothing but here what? Axis of parabola. Okay. And next one is least length of focal chord is length of latus rectum. So least length of focal chord means what is the meaning actually? Focal chord means it is nothing but a chord which is passing through focus. So suppose this is the parabola and this one is the focus, then here this is focal chord and this one is focal chord. So all these are actually here meant as focal chords. Now among all these focal chords here, the least length focal chord is nothing but this one, that is exactly latus rectum. Okay, therefore the least length of focal chord is length of latus rectum. So whatever points now we have been discussing, these are meant for all kinds of parabola. Okay, next one, two parabolas are said to be equal if they are having same length of latus rectum. Okay, two parabolas, when can say here equal? While taking the circle concept, we can say two circles are equal when their radius are same. Understand? When the radius is same, then the two circles are said to be equal. So if they are of this model, that means here radius is same, however centers differ, but we can say the two circles are equal circles. In the same way, two parabolas are said to be equal. When can we say this concept here? Whenever they are having same length of latus rectum. So two equal parabolas, whenever it is given in a data, you have to understand both the parabolas are having same length of latus rectum. That is, if one parabola is like this, it is having the latus rectum as here suppose some k units, then another parabola, whatever the shape it is here, suppose it is in the shape, then this also here how many units? K units. Then we can say these two parabolas are here equal parabolas. Okay, and next one, two parabolas can be drawn through ends of latus rectum. Now the question will come here, how many parabolas can be drawn through the ends of latus rectum. That means if you are taking, this is one parabola and this one is our latus rectum, then another parabola you can draw exactly like this. Okay, now in this way you can say this is the first parabola and this one is the other parabola. Therefore, through the ends of latus rectum, two parabolas can be drawn. And the next one is here, students, observe this, already we have done earlier also. Tangent at vertex comma directrix comma latus rectum are always parallel. Moreover, tangent at vertex is exactly midway between what here, directrix and latus rectum. That means however the parabola is given, suppose parabola is in this way, then this is our tangent at vertex and this one is the latus rectum and this is our directrix. Okay, suppose this equation you are having ax plus by plus c1 is 0. Okay, then immediately this equation if I take ax plus by plus c2 is 0, because both are parallel, therefore the two equations differ by constant term. Then what about here, this equation, it is nothing but ax plus by plus c1 plus c2 divided by 2 is 0. Understand? One of the important concepts while doing parabola problems, the tangent at vertex is nothing but exactly parallel to both of these latus rectum and directrix. Moreover, it is exactly lying in midway between the two lines. Okay, students, so these are very important points whatever we have observed, not only for any that is horizontal kind of parabola, but these are here applicable for even oblique parabolas also. Okay, let us observe here some problems basing on whatever concepts we have learnt. Observe here, first one, find equation of conic whose focus is -1, 1 and directrix is given, eccentricity also given as here 1. That means here the problem based on whenever in any data focus is given, directrix is given, eccentricity is given. Okay, focus given, directrix given, eccentricity given, then the concept is nothing but simply SP equal to E times PM. Okay, that means the definition, basic definition, locus of all points, like that we have definition. Based on that one we got this kind of value. Okay, now what is P actually here? The P is nothing but any point on the curve. So that point P you can start with x1 y1 or directly you can use as x comma y. Suppose first problem I am taking, suppose it is x1 comma y1. So P is any point x1 comma y1. Now they are asking about here equation of conic where focus is given, directrix also given. Therefore, if I apply this formula, then this is nothing but under root of x1 plus 1 whole square. Okay, plus y1 minus 1 whole square equal to eccentricity given as here 1. That means it is 1 into, this is our perpendicular distance. So mod of x1 plus y1 and divided by how much it is here, root 2. Got all of you? Then if you do cross multiplication and simplify, just now while doing the previous concept we have observed, students, this one is nothing but exactly what kind of lines? Pair of coincident lines. Okay, pair of coincident lines. Why we got that value here? Because the focus is falling exactly on the directrix. -1 plus 1 is 0 here. Therefore you got here exactly coincident lines. If I do the simplification, 2 into x1 square plus 1 plus 2x1 plus y1 square plus 1 minus 2y1 equal to, this is x1 square plus y1 square plus 2x1 y1. Okay, that implies here if you take all the values on one side, you will get here x1 square plus y1 square minus 2x1 y1. First I am writing the homogeneous part, that is second degree, and here also second degree. Now this is plus 4x1 and this is here minus 4y1. After that this is 1 plus 1 2 and this is here 4 is 0. So you got here x1 plus y1, but here minus 2x1 y1 is there. So minus y1 plus 2 whole square equal to 0. That implies the lines you got here coincident lines. Therefore the locus of P is nothing but how much here? Pair of lines and which are also coincident. Okay, and these lines, observe here how they are actually, they are passing through exactly focus. -1 and minus 1, that is minus 2 plus 2 here, that is 0. That means if at all just they asked you about locus, then we can stop here, that is x minus y, this is here x minus y plus 2 equal to 0, and we write the conclusion as here pair of parallel lines but which are coincident. Okay students, so in general not only this one, suppose if I give just here 2x plus y, then what we write here 2x1, then you will get here some other kind of value, that is nothing but depending on delta value 0, not 0, etc. But we will obtain here a second degree equation. Okay, second degree equation is our answer in these model problems. So first one, whenever a data given as simply focus, directrix, eccentricity, then this is our formula. Okay, and next second one is given as here find coordinates, that means here coordinates of all kinds of values, that means here focus, vertex, etc., all kinds of values, and again equations of lattice rectum, ends of lattice rectum, etc., all values. So x square is minus 4y, basically the diagram is of this model. Okay, this is the diagram. One must have here complete here knowledge about the diagram. That is very important students, because once you are having the diagram, problems will be sometimes very easy. Okay, so this one is here x square is minus 4y curve. So given curve is x square is minus 4y and it is of the form x square is minus 4ay. Therefore a equal to how much here? 1. Don't write any time a as minus 1. Okay, therefore here this is our vertex exactly, that is 0 comma 0 vertex. And what about here focus? It is 0 comma minus a. So here it is nothing but 0 comma minus 1. This is our focus. And next one is here, this is directrix. So how is the directrix here actually? This one is here, this is the lattice rectum you got, that is y equal to how much it is? Minus a, equation of lattice rectum. And now this is y equal to 0, equation of tangent at vertex. Then what about this value here? It is 0 comma a exactly. Therefore this line is nothing but here y equal to a. Now in this problem, what is that a value? 1. Therefore here equation of lattice rectum is equal to, implies y equal to how much students? It is minus 1. And next equation of here tangent at vertex, what about this value here? This is nothing but this implies y equal to 0. And next one equation of directrix, this is nothing but how much? Y equal to a means 1. Okay, now these are regarding equations. And focus of course you found, that is 0 comma minus 1. Vertex is here how much? 0 comma 0. Moreover axis is what here? The axis is exactly y axis, and that means this equation is what here? X equal to 0. Okay, so this is equation of axis. Like this, once any curve is given, we can find here each and every value. Now suppose a problem is asked like this, that is find vertex of the parabola y equal to ax square plus bx plus c. Okay, now this one already you have observed students while the time of here that is quadratic equations and expressions. Okay, so whenever you have done quadratic equations and expressions, you are much aware of that curve ax square plus bx plus c. There we have taken actually f of x is ax square plus bx plus c, whereas here we are taking it as just a quadratic, that is a parabola. Now they didn't mention about here a value, understand? That means the parabola can be of this turn or the parabola can be of this model. Okay, if a is positive, then this is the value, and if a is negative, then this is the curve, right? And vertex means however it is, vertex remains the same. Now what is the vertex formula? Actually while doing quadratic equations and expressions, you have taken this is exactly minus b by 2a, and this value is 4ac minus b square divided by 4a. Hope all of you remember this one. And that is same even here also. Okay, so whether the curve is upwards or if it is downwards, but this point is one and the same. Understand all of you here? Now while doing this one, actually y equal to the curve is ax square plus bx plus c. Understand? Then how we got these values here? You got it as y equal to, if I take a common, then it is x square plus b by a into x plus c divided by a. And after that we want to get a perfect square. To that purpose here x square plus we multiplied divided by 2 here, and this one is x here plus b square by 4a square, and this one is plus c by a minus b square by 4a square. Okay, so you can get in this way. Now from these three, actually what is our observation? It is a perfect square, and hence you got the value as here y equal to a into, understand, x plus b by 2a whole square, x plus b by 2a whole square. And after that this value is nothing but, if I take here 4a square as LCM, then this is 4ac minus b square. Got it now? Therefore, what about here final conclusion? This is y equal to, I multiply this value a into x plus b by 2a whole square, and next value if you multiply with this one, it is nothing but 4ac minus b square divided by 4a. So finally the value is nothing but here, that one means here I am taking this side. So a into x plus b by 2a whole square and equal to this side you got, it is y minus 4ac minus b square by 4a. Okay students, now finally we are going to divide with a also. So if I divide by a, then what about the result here? X plus b by 2a whole square is equal to, it is 1 by a, and into y minus 4ac minus b square divided by 4a. Okay, even though you know about directly the vertex, but I have done the total to discuss about some other new points also. Now students, observe, this is exactly of what form here? X minus alpha whole square equal to mod of 4a, that is plus or minus 4a, and into this is y minus beta. Okay, where alpha comma beta, the vertex is what here? Minus b by 2a comma 4ac minus b square by 4a. So the vertex here alpha beta is nothing but whatever the quadratic concept you have done, the same thing you can write, minus b by 2a comma 4ac minus b square by 4a. Of course there we have represented this as minus delta, which is our discriminant, right? And next one is here the important concept students, that is the length of lattice rectum. However, a value here, this a value positive or negative, but this value if you compare with mod of 4a, then it is nothing but exactly in what position here? Length of lattice rectum. Okay, so in these model problems, length of lattice rectum directly you can write here 1 divided by mod a. Okay, however the curve is given, y is ax square plus bx plus c. In this model a curve equation is given, then to this if they ask about what is length of lattice rectum, just write it as the answer 1 by mod a, that's it. Understand? No need of doing the entire thing. So note down students, the important formula for it is now, to any curve y equal to, that means y equal to ax square plus bx plus c. Okay, to this curve what is the formula for length of lattice rectum? Okay, so length of lattice rectum is equal to 1 divided by mod a, that is mod of coefficient of here x square. Got all of you? This value we have to write, and suppose the curve is exactly of this form, that means if the curve is x equal to ay square plus by plus c, okay, in this way the curve is there. That means this will take the form how much? Y minus some value whole square equal to constant into x minus some value. Okay, so in this way you will get, again here you will get exactly which value? 1 by a. Therefore whether this curve or this curve, simply here I can say length of lattice rectum is 1 divided by mod of coefficient of y square. Of course you have to make note the standard form is important, y equal to or here x equal to. After that once you reduce the equation completely in this form, whatever the result they ask you can here solve all the values, right students? And now here, how are these two curves also? If you observe, these two curves again if you observe, one is here symmetric about, one is again image of the other with respect to the line y equal to x. Okay, so take care of this formula, very important. Vertex means simply you can make use of here at x is minus b by 2a, the minimum value or maximum value of the expression, that is nothing but our 4ac minus b square by 4a. So that is our vertex, whether a is here positive or negative. Understand, curve is upwards or curve is downwards, but vertex remains the same, right? Now suppose students observe here this model problem. They ask about here find coordinates of focus, vertex, equation of lattice rectum, all kinds of values whatever we have proved while doing the theorem. So if this is the curve, this is second degree in y and this is the problem second degree in x. Okay, so whenever a problem is asked basing on this model, how to solve that kind of problem. So here observe where is the second degree. The second degree is coming for y. Therefore, put all y terms on one side, send the other variable to the next side. That means I will put here y square 4y. Moreover, second degree if it is in y, try to write it as a perfect square. To get the perfect square always here y square is there, 4y is there. To obtain the perfect square, how much we require more here? 4 we require. So this 5 you just write it as 4 plus 1. Okay, so I am writing first of all y square plus 4y and plus 5 is equal to x. So wherever second degree term is there, just write the second degree term values on one side, rest all you send to the other side. Now here I want a perfect square. To that purpose in 5 I am taking here 4. Okay, 4 I am taking, the leftover 1 I am sending to the other side. Then what is this value here? It is y plus 2 whole square equal to x minus 1. Now you got the completely what kind of value here? Y minus beta whole square is equal to 4a into x minus alpha, right? This is the standard form for this equation. Then what about here the curve nature, how it is actually? It is a horizontal, that means in this way the curve is, right? Now what is the vertex here? Alpha beta. So here what is the vertex if you compare these two? The vertex, simply students, instead of comparing all these, one of the methods you follow just like this, y square equal to x. Okay, just you follow in this way, y square equal to x. So what is your y value here? The capital Y is nothing but here y plus 2 and capital X is nothing but here how much? X minus 1. Now what about here vertex to this one? It is actually 0 0. Okay, x comma y vertex if I write, all you will get in terms of capital letters x comma y. This is 0 0 and this 0 0 is nothing but in this one what are the values here? That implies here y plus 2, this is x minus 1 comma y plus 2 is 0 0. That implies what is the vertex here in terms of small coordinates? It is 1 minus 2. So directly also you can write 1 and minus 2 as vertex. And what is the next requirement here? 4a. What is 4a if you compare here? Y square equal to x, 4a is here 1. 4a is 1 implies length of lattice rectum is here 1 unit. Okay, and here what is a value? 1 by 4. So a value you got 1 by 4 here, and this value a value you can apply to use here focus and all. So what is actually focus coordinates for us? It is for this kind of parabola a comma 0, that is capital X capital Y equal to here 1 by 4 0. Understand, this is the value. But while doing the problems directly you can write in this way, that is the focus, first you write the value, that is nothing but how much here in terms of capital letters 1 by 4 0. Then this 1 by 4 0 actually we equate it to what here in terms of old system, that means it is x minus 1 comma y plus 2. Okay, this is equal to here 1 by 4 0. Then you can write here x is 1 plus 1 by 4 y is minus 2, that is x comma y equal to here 1 by 4 plus 1 comma this is minus 2. So 5 by 4 comma minus 2 is nothing but our focus. But directly also students, you try to write here in this way, that is nothing but here first observe what is the focus for y square equal to x. It's nothing but here 1 by 4 comma 0, and to this one just add the coordinates of vertex. What are vertex coordinates? 1 minus 2. Just add these coordinates, that means here I am writing plus 1 and here I am writing minus 2. Just add. Understand? Thereby it is nothing but 5 by 4 comma minus 2. So write the actual value here, and to that here add exactly the vertex coordinates. Those are alpha beta. Understand? And next one is our directrix. Okay. So equation of directrix. So what about here equation of directrix? Equation of directrix, actually what is to this curve? Actually this is nothing but x equal to minus a. Okay, so formula is x is minus a, but what is x here? X minus 1. That implies x minus 1 is minus a value is 1 by 4, that is minus 1 by 4. Okay, so here if I take this value this side, then it is x is 1 minus 1 by 4, implies x is here how much? 3 by 4. Okay, so 4x minus 3 equal to 0 is equation of directrix. And in this way latus rectum length you got, equation of latus rectum, everything you can find. So what we have to do is first in this model problems, once here second degree is in y, therefore arrange y value as here perfect square. The rest you send all x values to the other side. Make it a perfect square by addition or subtraction. And after you got perfect square, then compare with the standard form in this way or like this. Okay. So I am comparing directly like this so that the problem can be very easy. So y square equal to x, which is of the form y square is 4ax, where 4a equal to how much here? 1. And vertex is here 0 comma 0, and therefore if I compare with the old system, these are the values. Or else directly if you compare here, alpha is 1 and beta is minus 2. After that focus coordinates just write as 1 by 4 0, a comma 0, then add alpha and beta. And directrix equation, capital X value is how much? Minus a. Then this x is nothing but x minus 1. A is 1 by 4 minus a, so we wrote minus 1 by 4. In this way students, the problems you can solve when the axis is here parallel to x axis or y axis. Okay. Now suppose if I take this problem, that is here 3x square. What is x square coefficient? First of all you have to observe what is x square coefficient there? 3. And moreover you cannot write it as a perfect square because 3 value is there, so I can't write it as here perfect square. Therefore what I want to take is first second degree is in x. Okay, second degree is in x, so let us write all x values on one side and the leftover terms let us send to the other side, that is this side minus 5y plus 2. Okay, so in this way let us take. Now I want to take this one as a perfect square. To that just take here 3 common. Suppose here you are having 4x square, we would have continue, 25x square, we would have continue, but it is not like that 3 value. Therefore let us take here 3 common, x square minus 3x, okay, and equal to this is as it is. And now this is 3 into x square. I want a perfect square. To get a perfect square, let us multiply divide by 2. Okay, x here, so 3 by 2. For x already square is there, and therefore for 3 by 2 I am writing it is 9 by 4 minus 9 by 4. Okay, and this one is minus 5y plus 2, right? Now what about here up to here this value? It is x minus 3 by 2 whole square. So 3 into x minus 3 by 2 whole square, and I am separating this particular value. Okay, so this is minus 27 by 4. Let us take that value to the other side. So it will become plus 27 by 4. Okay. Then this is 3 into x minus 3 by 2 whole square and equal to here minus 5y plus what is this value? 8 plus 27, that is 35. So 35 divided by 4. Okay, then let us take this value 3 also the other side. Then x minus 3 by 2 whole square equal to 1 by 3 times minus 5y plus 35 by 4. So now you will get a doubt, you got exactly of that form but still we didn't get the standard form. What is the reason? How I can say I didn't get the standard form? The reason is here, because here I can't continue in this way. The reason is here. The standard form is what actually? X minus alpha whole square equal to 4a into y minus beta. Observe students, a very important point while taking the standard form, every time make sure this y coefficient inside the bracket, okay? Inside the bracket the y coefficient whether it is 1 or not. And here it is x coefficient whether it is 1 or not. Then the problem easily you can solve by just comparing with the standard form. So make sure y coefficient has to be 1 inside the bracket. But here still we are having here minus 5. Okay, not even negative symbol also. Take complete all value, it is only plus 1 y coefficient inside the bracket. Then I am taking here minus 5 common here and thereby this is y minus it is here how much? 7 divided by 4. Okay, so if you just check here 35 divided by 4 and this 3 remains same. Now you got exactly the standard form. So this is the method you have to simplify in this way so as to obtain all other values. Now you can compare students, what is this standard form you got exactly? It is nothing but in the form x square equal to how much is this value? Minus 5 by 3 times it is y. Okay, so it is just like our x square equal to 4ay type of parabola, minus 4ay type of parabola. Then this is of this model downwards. Okay, downwards parabola. What is our 4a here? It is 5 by 3, right? So in this 4a value no change at all, as it is we can write it is 5 by 3. After you got this 4a is 5 by 3, that implies a equal to how much here? 5 divided by 12. Okay, and next one is here vertex. Vertex is now how much you got? 3 by 2 comma 7 by 4. Okay, because what are our x and y values here? We have taken capital X is nothing but how much? X minus 3 by 2, whereas capital Y is nothing but here y minus 7 by 4. Okay, so like this we have taken. Therefore the vertex is nothing but alpha beta is here 3 by 2 comma 7 by 4 you can use, right? Now next other values you can use, students. What are the other values you can get here? That is focus. First I am writing focus formula. What is actually to this curve focus formula? It is 0 comma minus this is the value. Okay, so here if I take now this is the focus 0 comma minus a. So now here also I am writing just like 0 minus a first. Okay, just I am writing this is 0 minus a. What is minus a? Minus 5 by 12. But to this how much you need to add here? These values. So here I am adding 3 by 2 and here I am adding 7 by 4. Simply you can obtain all other values. Okay, and in this way you can find directrix. What is directrix to this parabola? Directrix is falling like this. Okay, so this is the directrix, that is here y equal to a. Okay, so here in place of y, capital Y equal to a means 5 divided by 12. This is our directrix equation. Okay, now capital Y means what is the value? Y minus 7 by 4 equal to 5 by 12. So if you simplify you can get directrix. So this is the method of solving the problems whenever equations given, one is in second degree, other is in first degree. Get here completely perfect square in terms of y, and here one is second degree, the other is in first degree. So here we'll get completely perfect square in terms of x. Okay.